Hello, everyone. Welcome to this beautiful session about serverless, but from a data perspective. So it's about discovering serverless data options for serverless apps. And this is going to be from an Azure perspective. So we do talk a lot, at least I do talk a lot about serverless for a couple of years now. And when we focus on it, usually what we end up talking about is, the function as a service. How can we host our compute layer on serverless? That's the discussion that usually dominates, most of the sessions around. And that has been my focus as well. Recently, I kind of started focusing into, hey, it makes sense to have the serverless, the compute layer serverless, but what about the other pieces? Can we do eventing in a serverless fashion, and so on and so forth? And finally, I was like, when I was sending a session for this conference, I was like, hey, why don't we talk about the full data stack? I mean, what are our data options when it comes to building serverless apps and platforms? And there are a couple of those. And that's what we're going to discuss today. So I am Darian Dem. I am leading Azure application development for Middle East and Africa at Microsoft. Feel free to connect on Twitter and LinkedIn. We might not have a lot of time here for question and answers, or some questions might come to your mind after the session, and that's perfectly fine. Twitter and LinkedIn is a good place. Give me a second. Twitter and LinkedIn are a good place to reach out whenever you have questions. And it looks like my throat is going to slow down this session a little bit, and that's okay as well, because I usually speak pretty fast, so that's fine. I'm sure some of us will appreciate me slowing down. Okay, let's start. So what is serverless? Let's set our expectations, right? There are a lot of chiefs out there and jokes out there that, people crashing servers and then calling, hey, this is what serverless is, right? And that's kind of joke part, because this is kind of the serverless that we have today. I'm not going to say if it's if it is where it is supposed to be, and we will talk about that, but serverless essentially what we have dreamed up for years since we had this thing called cloud. So for like 10 or 15 years now, when we started talking about cloud, our dream wasn't, provisioning VMs. Our dream was to really, be on a platform, be on a cloud operating system where we don't have to worry about the underlying plumbing. Right. And the example I usually give is like, when you're writing some code or when you're writing an app, let's go with Windows. As a developer, if you're using C# or even Java, doesn't matter, a high-level programming language, you don't worry about do I have a describe attached from SATA or ID or whatever, right? You don't worry about that. You have a logical file system that you can access and put files into. You open up a stream and you write into it. So that should be kind of the same thing when we're building applications for the cloud. And that was the dream place where we wanted to be. Instead, we're writing code that requires the knowledge of, the fact that our application will be running on multiple servers, right? Because ideally, that's the physical world, right? So the physical world should be abstracted away from my logical development world. So that's kind of the ideal world. But are we there yet? We're getting close, and that's what serverless is about, at least for me. Okay, I gotta feed in my throat so that, because of this sore throat that I had a week ago, it's still in there somewhere. Okay, so setting up the expectations is what we said, right? So a serverless dream, no provisioning. We shouldn't provision anything. Again, this is the dream. I'm not saying this is the case in all of the services that we're going to talk. But that's our dream, and we're going to assess every service that I bring in onto the stage from these perspectives, right? There should be no provisioning. I shouldn't come in, you shouldn't ask me as a cloud service to, increase my provisioning amount just because, I'm bringing additional load. It should not be the case. I should just come in and say, hey, I want to use that service and we're done. And I should use it as much as I want. So that's the dream. Pay-per-use, not pay-per-provisioning. So that's a very tricky part, because, when you do provisioning and then you start paying for the amount of resources that you provision, not necessarily for the amount of resources that you have used. And that's not our serverless dream. Our serverless dream is to come in, say, hey, I want to use that service, and every time I use it, I'm going to pay you, right? I'm not going to pay you a particular fee just in case I might use that service during the next, whatever, day or two. No, it's called provisioning, and it, at some level, I will be provisioning. If you have provisioning, I'm definitely, there will be some time that I have over provisioned or under provisioned, which means I am either, using more resources than I need and paying more resources than I am using, or I am under provisioning because I'm kind of late into predicting my spike and I didn't provision properly. And then I'm losing customers, or I'm losing money, right? So that's not the serverless dream. We don't want to be there. And all of this comes with transparent scaling. Transparent scaling means, hey, you shouldn't ask me when to scale. We shouldn't even, that whole scaling thing should be something that happens in the cloud somewhere. Someone handles that, not me. So that's not my serverless dream. I don't want to come in and say, hey, please add me another node or something. No, I don't want to do that. I don't want to monitor my, I will monitor my consumption for sure, but I don't want to monitor my consumption and so that I can figure out how much resources I'm going to need. And then, this whole thing goes into, over provisioning, under provisioning story, right? So the ideal dream is I come in and I say, hey, I want to use that service. And you're like, sure, go ahead, use it. If you don't use it, you're not going to pay anything. And then every time I use it, I pay you a particular amount of money and we're done. And if I want to use it a lot, you're like, okay, give me some more money, and that's it. So that should be our relationship with the service. So that's what the serverless, at least my serverless dream is. And that's the baseline we are going to use moving forward in this session. So the first option, I'm sure if you played with Azure a little bit, you might have guessed this, Cosmos DB is the first option. And let's go into it. Let's go into it. So I have a bunch of information in these slides. And we will go through that. We will talk. So when it comes to billing, and why do I start from billing? Because here's the interesting thing. A couple of days ago, not necessarily a couple of days, a while ago, I had this discussion with, unfortunately, I don't remember his name, but someone on Twitter. They were saying serverless ended up being a licensing model, which I'm okay with it, and I agree, to be honest. Serverless is not necessarily an architecture, because sometimes there's confusion around serverless versus microservices. Serverless, it's not. Think about the dream that I've just shared with you. That has nothing to do with a particular software architecture. You might be able to align it. You might say, hey, it looks like this dream that you have is a perfect world for an event-driven architecture to live. Oh yes, it might be, and it might not. It doesn't matter. That's what I'm trying to say. It doesn't matter. So serverless is essentially, yes, I agree, it's a licensing model. So that's why I'm starting the discussion from billing, because we need to understand, my dream was mostly about provisioning and the ability to use the services pay per use, right? That was my dream about. And the auto scaling, obviously. So, and billing is a big part of it. So when it comes to Cosmos DB, the big critical thing to understand is there's this concept called request unit. This is not going to be a session about Cosmos DB, right? We'll just focus on a couple of things that relates to how Cosmos DB is serverless. So request unit is a unit of measure that measures the complexity of your query, the amount of data that you read or write, transferred, right? The amount of data that is being scanned or stored, right? All of that. The total cost of a query, the processor time, the memory that's been used, everything. Okay? Think about all of that combined into a single unit. And for every query that you run, as a response, you are getting a request unit. So every time you run a query in Cosmos DB, you know how much it costs you. And that's it. So Cosmos DB has a couple of different pricing models. Okay? It has a provisioning-based pricing model as well. I'm not going to go in there because it's not serverless. So what aligns with my serverless thinking my serverless dream is the serverless consumption tier of Cosmos DB. So it is request unit based. You can handle traffic bursts on demand without resource planning or management. And yes, I'm reading my slide right now. Bills only for resources used per that database operation with no minimum. What no minimum means, if you don't do anything, you're not going to pay for anything other than the data that you're storing, because even if you don't do anything, you're still storing data in Azure, right? So you got to pay for it. No resource planning or management. Again, bills only for resources. Oh, I have this pasted twice. Okay, so that's how serverless is Cosmos DB. So what can you do with serverless DB, right? With Cosmos DB, serverless DB, with Cosmos DB. So it's an NoSQL database. The beauty of it is it has 5. Did I miss anything? 2, 4, 5. 5 different APIs. Again, those are projections, but on a high level, what that means is you can come in, talk to this service, which is a database, with T-SQL, with Mongo. Let's consider those different languages, right? Mongo, Gremlin, Table, Cassandra. So you can come in and talk with 5 different languages, not into a single service. When you're creating the service, you're selecting the language that you're going to talk to the service, by the way. It has 5 consistency levels. Again, we're not going to go there, but the ability to have 5 different consistency levels and that flexibility is important, because here's the beauty with Cosmos DB. It has, like you see on the bullet number 4, it has 4 SLAs. Availability SLA, throughput SLA, consistency SLA, latency SLA. So think about it. How can a service have a latency SLA? I mean, what's going to happen if I really throw a very complex query or something that requires to read a lot of data or whatever, right? So first off, the SLA isn't 100%, but then, what it means is when you're throwing complex stuff to Cosmos DB, your query will still be under the SLA, but you are going to pay for it. So it is going to cost more. If your queries are not optimized, if your queries are not well built, the service will still hit your SLAs, but you will pay more. So that's very important to understand. And that's why maybe you might have heard that people saying Cosmos DB is expensive. This is one of the reasons. You have to optimize things. The other thing is, and this is kind of a trick, is Cosmos DB by default indexes everything. Disable things that do not require indexing. Disable fields that don't need to be queried or whatever, right? Fine tune it. That's the trick. And it comes with turnkey global replication. It's indeed turnkey. So all of these features, they're in a single service that is serverless. You only pay for what you use. So cool. Show me something. Let's see it in action. So here I have a Cosmos DB account. I've already created. I got some data in here. I'm going to go into there and show you what's happening. I'm going to go into Data Explorer. Okay. So we got a sample DB, open up the container and go into items. So you're going to see that I have a bunch of items in here. Let me select one of those. And it's a pretty small item. There's only an address in it. There's not much, right? So let me start a new query though. Hit this one. Select star from C. Okay, we will just simply do a select star. I will execute the query. And we got the result down there, all of the JSON documents, right? So now I'm going to click on query stats. And you can see the request charge. So this one did cost us 2.56 RUs. Okay, how is it calculated? Google it. We can't cover it as part of this session. But there are details documented so that you can go and take a look at it. So let's do something like this, where I'm going to add in a where clause. I'm going to say where, let me copy paste from here, c that address equals to or like, right? Northeast 37, whatever. Okay. Let me do this just the regular SQL way. And I'm going to run this now. Okay, we got the result. This time you can tell that there's only a single record. And let's go into query stats. 2.83. So we are paying more to this query than we paid to select star. It is what it is. I'm not going to say it makes sense, because this might have been totally different if we had a lot of data in this collection, because the cost it takes to fetch a lot of data might counteract the cost it takes to filter out data. This is a real thing. Sometimes you can see, when you have a lot of data, you can see that looking up and selecting a single item and fetching that might cost less than going and doing a full select star, because you are doing a lot of read to be able to fetch all of that data, right? It's not the case here because the collection is really small. What I'm trying to say is your query, the cost of your query relates to a lot of different things, including, if did you enable indexes for particular fields or not, right? And that's going to be reflected to your use, which means you have a lot of control over this, how much it costs for you. And so far, this is the only thing that I'm going to pay because this is a serverless database. Cool. So let's continue. Our next option is Azure SQL Database Serverless. So I feel like this is going to surprise some of you, because this is kind of a gem that is not very well known. I don't know why. This isn't as beautiful or crazy as flexible. I'm not going to say this is as good as maybe Cosmos DB, but this is still a pretty nice option, because this is a SQL that we all know. For years and years we have known, right? So imagine the SQL that you have today, Azure SQL database managed, right? And imagine that it can be serverless, or at least close to serverless. So look at the graph on the right hand side right now. So the green lines are the provisioning. Okay. The orange line is the actual usage. Okay. The green lines are the usage that is being reflected in Azure. Essentially, the virtual cores built, you're paying for those. There are still cores, there are still virtual cores. That's still the unit of scale. So the green lines are the vCores that you paid. The orange line is the vCores used. And from what I can tell right now, at the beginning of this graph, everything looks really beautiful, right? Because the green lines are matching perfectly, pretty much perfectly, the orange line, and that's what we want. We don't want to overpay. We don't want to obviously underpay or under provision. So here what's happening is we are setting up a minimum and a maximum virtual cores for the service. I know this kind of goes against my dream of, hey, I don't want provisioning. Yeah, we are still setting a maximum and a minimum vCore. But again, those settings, they're not affecting my billing other than the minimum vCore. And we will talk about that. So the maximum vCore is not affecting my billing, but the minimum vCore does a little bit. You can see that, this blue line represents the minimum vCore in this setting. And if my actual vCore use goes under the minimum vCore, I'm still paying for the minimum vCore. And that's not ideal. because again, that's not aligned with my dream of paying for what I use at all times. But at least I had that dream realized in part of my application usage timeline, right? But then I have one additional trick, which is auto pause delay. So the auto pause delay is something that you can configure the parameter. The system monitors your SQL database usage. And if the database is not used, for example, for an hour, it's taken off. There's no minimum vCore, 0 build. So I can at least scale it down to 0. This scaling doesn't happen per second basis. Unfortunately, today, as of August 2022, the auto pause delay can be a minimum of 1 hour. So you have to wait for 1 hour. You have to still pay the minimum vCore during that period in time. Then when the first request comes in, the server will be up and running again. And during the warm-up, there will be a little bit of a delay. So this isn't, I wouldn't say this is a perfect fit for high performance scenarios. Again, don't get me wrong. I mean, when the database is running, when you have at least the minimum vCore, then you're good. The database is up and running, so you're not you're not going to have any problems in there. But if the pausing has happened, then there's going to be a cold start type of situation. Yeah. So again, this isn't 100% aligned with our serverless dream, but it's close, and it's helping a lot. Think about, how would you do this if these features weren't available, and how much additional money would you need to pay, right, to have this, to be able to serve the amount of load that reflects the scenario, right? So this is another option. So what can you do with it? Essentially anything, because this is SQL. This is the SQL that we know. This is not a different service or anything like that. It's again price performance optimized for single databases with intermittent unpredictable usage patterns that can afford some delay in compute warm-up that I already mentioned. The provisioned computer is priced for single databases. Okay, I'm kind of trying to make sure I'm not missing anything with my notes on these slides, or multiple data. Okay, here's the interesting part. This is a price performance option for single databases or multiple databases in elastic pools with higher average usage that cannot afford any delay in compute warm-up. Okay, so multiple databases in elastic pools with higher average usage that cannot afford any delay in compute warm-up. So elastic pools is out there if that's what you're looking for. Okay, so let's see auto pause in action. So it's not going to be really in action, by the way, because like I said, it takes an hour. But let's go in there. Come on, load it up. Cool. So you can tell that right now we don't have anything built. Application CPU built 0, 0, 0. So let me change this to 24 hours and apply. Okay, there we go. So I created this database a couple of hours ago. Okay, when I created it, it was active, so I was paying for it. Okay, and then it did go into auto pause. So right now, and you can tell that I have a query in here, right? This is the actual compute utilization. So right now it is paused. When I said auto pause in action, we're not going to see it in action pausing because it takes an hour to wait for it, and or I have to align this demo perfectly so that it's exactly at the end of that 1 hour. But what we can do is resume a database that was already paused, right? So that might be the trick. So let's do this. Let's go into query editor. and connect to the database. Let's give that a try. Did I write my password wrong? I'm not sure why it asked for my certificate, by the way. Okay, there you go. I bet this was the resuming scenario. Okay, there we go. So the database is up and running, and I'm going to say select tab 1000, run the query, and you see the data. So now we're going to go back to the overview page, and probably we're going to see when we go into the monitoring section. It might take a while though. We should start seeing some usage in here. So let's leave it as it is. Let's go back to our presentation, and we will come back to this and look at it in a couple of minutes. So that was our demo. That was it. So another option is Azure Table Storage. This is not new. This is actually pretty old. This was there from day one when Azure was out, right? So this is a pretty nice offering though. This is a pretty niche offering, but if your use case fits into this is a beautiful service. So the service charges, for the storage. It's actually part of the Azure Storage accounts, the table. There are two table services. The first one and the original one is under Azure Storage tables, Azure Storage accounts. And then the second one is Table Premium API, which is part of Cosmos DB. Cosmos DB can speak the same language, but when you go with Table API on Cosmos DB, you're going to have additional capabilities that I'm not going to talk about for now because it's not our topic. But the limitations, most of the limitations that you're going to see in here are not there when it goes to Cosmos DB. When you decide that language on Cosmos DB, and the pricing will be different as well. So this one is the classic table storage, which is highly limited, very cheap, and really nice serverless. So we are paying per storage in gigabyte per month. We are charged per 10,000 transactions. Okay, paying per transaction is just beautiful. There's a maximum table size, 500 terabytes. 500 terabytes is a lot, by the way. Maximum entity size. This is a NoSQL solution. Okay, a flat NoSQL solution. And there's a limit per storage account, which is 20,000 transactions per second. Okay, those are important limitations I wanted to put out there because this thing, there's no provisioning. There's nothing. It just scales. Those are just REST APIs, and you just use as much as you want, and you will pay per transaction. You will pay for the amount of data you stored, and that's it. So, but I wanted to include the limits so that it doesn't feel like it's limitless. It is. 20 transactions per second. If you're gonna write stuff into it, up to 2,000 entities per second throughput for a single table partition. It's not a single table partition, and you can have, I don't know if there's a limit in the amount of partitions you can have, to be honest. I don't think there would be, but I'm not sure, but I don't think there is. Otherwise I would have included it in there. So this is a beautiful service. So what can you do with this? It's a flat non-relational data storage. It has a partition key and the row key. It's essentially a clustered index. No secondary indexes. So that's the tricky part. No secondary indexes. You can't do it. You can do it if you go to Cosmos DB, but that's a different story. You can't do it here. There's only two: row key, partition key. That's it. Partition key, obviously, as the name suggests, used for partitioning. Row key. So storing data sets that do not require complex joins, obviously that's NoSQL. Foreign keys, NoSQL. Or store procedures, not just available. Functionality pretty limited, and can be normalized for fast access. Yes, sir. Partition key, row key. If you can do that, you got yourself a really very, very cheap NoSQL solution that is serverless, fully serverless. Quickly querying data using a cluster index, query huge sets of structured data, and so on and so forth. tables will scale on demand. That's kind of, well, I guess I said it, but it's kind of, by default. There's no provisioning, no scaling, nothing that you have to worry about. If you're not hitting the service limits, then you're good. Yeah, there's no cold start, warm start, whatever. No, it's just REST APIs that you're going to use. It's beautiful. I really love it. I'm a fan of table storage. People don't like it because it's too limited. Work around it, or maybe it's not the good fit for a particular use case, and that's okay. Not everything will solve every problem, but if you have a use case that can fit into table services and you're using something else, you're throwing money out of the window. Why would you do that? Okay, so maybe before we go into this, let's take a look at and refresh. Maybe, like, I don't see a refresh button, so I'm gonna do this trick. Oops. Oh, that's another way to refresh things. Okay, at least we can see our query in here. So now, oh, there we go. See, the database came up. Cool. So it did auto browse, and now it's active. So I can leave this DB as it is without being worried that I'm gonna be consistently paying for it. If it's not used, it's auto browse. So let's leave it as it is. Okay, cool. So the final one, Azure Serverless Storage. I put this like as a stretch, but I still think like this should be in your mind. This should be in your list of things to consider when it comes to store some stuff. It's not a database, but it's gonna get very close. Let me show you. Don't leave me. Don't think like, hey, this is just storage. No, it's more than that. I'm gonna show you. I'm not gonna do a demo, but I will show you. So the billing, paper storage, bandwidth, and transaction. That's pretty much how table services comes in. Okay, so that's easy. What can you do? Store files. But here's what's the interesting thing about Azure Storage blobs that is not very well known. So recently, there have been an additional functionality that's released, which is called blob indexes. So when it comes to querying something, not necessarily the content of the blob in this case, but finding the right blob. So I would say that's still a type of querying, right? So you can have user-defined key value tag attributes for every blob that helps you query and find. So think about it. If you can use these key value tags, and you have all of these scenarios will be, I will shape those mostly around storing JSON documents in blobs instead of storing JSON documents in a NoSQL database. If you don't have those crazy queries and you just need a couple of fields, maybe you can put it into a table service because partition key, row key, but then the entity size is only 1 meg. So if it's larger than that, but you are still querying into a couple of fields, then you can have those key value attributes and still store JSON documents in Azure Storage, and you're done. The beautiful thing with this is that you can have, you can serve the JSON files directly from the storage without any compute layer in front of it. It's just like serving files. I can hear you saying, hey, what about authentication and stuff? Yes, there's going to be limitations on that front as well. You will either use SAS keys or that's it. Your application could be in Azure, and you can, if it's only your application using the JSON files, you can even authenticate through managed identities and stuff like that. So, but when it comes to public accessing to JSON files in terms of a single page app or something, maybe, SAS will be the only way to authenticate, unless you put something in front of it, which kind of kills the purpose, unless putting a serverless function in front of this is less expensive than having the JSON data stored in Cosmos DB. I don't know, worth investigating. But long story short, this is still a location that we can use to store JSON files, and we can have those blob indexes. The other thing that is really interesting is the blob query. So this is originally Azure Data Lake Storage Query Acceleration. So this is part of that data lake functionality. What it does is, I don't have a demo for this, unfortunately. It didn't make it to this presentation, but trust me, it works. You are sending a T-SQL query to query the content of blobs and then get you the result. So this is functionality that is available to data lake and data warehousing, but this is functionality that works on top of blobs. So you don't necessarily have to have a data warehouse. You can use the Azure SDK for storage, and you can send those queries yourself. Those are REST APIs at the end of the day. So again, it's not I wouldn't say this is a replacement for a full-blown, NoSQL database, but for minimal needs, knowing that you can do that in blobs, right? It opens interesting pathways. That's what I'm trying to say. Cool. So let's recap. So when we look at those 4 options, obviously I started from the best to, the best, which is best means in this case closer to my dream, and kind of started going a little bit further and further away, right? So if you're looking for a serverless NoSQL solution, Cosmos DB is the closest to go with. If you are looking for a serverless SQL, then we have Azure SQL Database Serverless. Then as another option, a little bit more limited maybe, but really crazy cheap, is table storage as a serverless NoSQL option. And finally, I call this a serverless data lake, blob storage, and the ability to use blob indexes plus blob query capability to query JSON content in the blob and then serve those outside. So hopefully these are helpful. These are the data options that get close to that serverless dream that I have. Cool. So I hope you enjoyed this session. Like I said at the beginning of the session, please reach out to me if you have any questions, or if something comes to your mind, or if you give it a try and then you have some questions, whatever. So reach out to me on Twitter and LinkedIn. Let me know your feedback about this session as well. Hopefully this is helpful and you liked it. Thanks to our sponsors and the Data Platform Summit team, because this has been my second or third, I don't remember the number, but every time I have attended this conference, I really enjoyed it and I really liked it. So huge thanks to those guys as well, keeping everything tidy and organized. They are doing a beautiful job with so many sessions in this conference. It's pretty huge and across different time zones. Yep. It looks like there's a prize to win. So go ahead. I'm going to leave the slide on screen. Go ahead, follow the instructions, and hopefully you will win one of those. See you.